Okay, continuing our quick review on statistics, let's talk about the standard deviation. Now, we're not go over the generalities. We are not going to enter into detail how to find the standard deviation because we are one of our big five, 4 steps in solving exercises. And then if you start finding the standard deviations through all the process, that is to find the variance, the distance from the elements to the mean, and then blah, 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 the variance, and the standard deviation is the square root of the variance, definitely it's gonna be in 4 steps, and it's not necessary. Here, what we need to be clear on is what is the concept of a standard deviation. So, to start with the concept, we are just going to define a standard deviation as a number that indicates how spread, let's say, how spread or how packed, I guess. So we're going to start by defining standard deviation as a number that gives us an indication of how spread or how far, how spread or how close are the elements of a list, are the elements of a list from the mean. So this standard deviation always refers to the mean, okay? So let's start by, again, putting some graph representation of this thing. So imagine that this is the mean of a list of elements, right? Right here is going to be the mean. I'm going to draw a list of elements in yellow. So let's say that I have one element here, another one here, another one here, and another one here, maybe. And some in green, they both have the same mean, but the ones in green, the elements are going to be one element right here. Okay, let's make it bigger. Another element right here, and another element maybe here, okay? So, as we need to analyze is how spread, how far or how close are the elements from the mean, check out the elements in yellow are like from here to the mean, from here to the mean. The ones in green will be like from here to the mean and from here to the mean. Now, which standard deviation is greater? The one of the yellow elements or the one of the green elements? As the yellow elements are more spread out from the mean, or the green elements are closer to the mean, so here that means that the standard deviation of yellow is greater, okay, is greater than the standard deviation of the elements in green, okay, because that's the concept, how far or how close are the elements from the mean. So that's what we need to understand right now, okay? Now, this has like an idea, let's get this scenario, this other scenario, because it's like there is a greater concentration towards the mean. So for example, you might have the case where we have the distribution here, and then again the ones in yellow are like one element here, one element here, or one element here, right? Let's say that you have two elements here in yellow, and here two. 1, 2, and here 1 in the middle. Let's say the elements in green. The elements in green are exactly, will have the same mean and will be equally far from the mean. So let's try to draw it as close as possible. So let's say that I have, here we have 5 elements. So 2 here, 1 here, 2 here. The ones in green, let's say that I have 1 here. I have 1, 2, and 3 here. And I have another one right here, okay? So this distance from here to here is the same as the ones in yellow, like from here to here. That, let's say that is the same distance, okay? Now we need to decide which standard deviation is greater. Again, because the elements in green are like more, like there is a tendency, there is more weight towards the mean, towards the center. And the elements in yellow are like the tendency like going far from the mean. Again, in this scenario, we still have that the standard deviation of the elements in yellow is definitely greater than that standard deviation of those in green, okay? Clear? And the last big aspect that I would like you to keep in mind, or for us to understand about standard deviation, is that I would like for you to think of the standard deviation as a unit of length, okay? As a unit of length. What do I mean? Let me give you an example. Let's say that we have this drawing here, right? Let's say that we have the mean is 10, and they tell us that the, let's put these elements in yellow, so they say that the standard deviation is, I don't know, the standard deviation of this list will be 3, okay? So, if they ask us at any given moment, okay, they might ask us, what is the value of an element that is 2 standard deviations above the mean? So we know what is the standard deviation. So we have 2 standard deviations. So that's what I mean. Take the standard deviations as units of length. So from the mean above, so that means to the right. So from this, I will take 1 standard deviation, that is 1 unit of length, and then another standard deviation. So this will be the element that is 2 standard deviations above the mean. Now, to know exactly the element, we know that this unit of length takes the value of 3 in this case. And here it takes, again, the value of 3 because this is 1 standard deviation. This will be the second standard deviation. So the element that is 2 standard deviations above the mean will be 16. That clear? They might ask us, what is the element that is 1 standard deviation below the mean? So 1 to this side, only 1 unit of length. We know that in this specific case, they say that the standard deviation takes a value of 3. So right here is going to be 7. That will be the value of the element that is 1 standard deviation below the mean. All right, I hope that this is kind of clear. Let's give another example for you to be, again, a little more clear on what do I mean with the standard deviation being a unit of length. We're going to be given a list, right? And the question would be, which elements are within, I don't know, let's say 3 standard deviations below the mean, okay? And let's say that they tell us that in this case the standard deviation will take the value of 2. And let's say that this is my drawing, this is my list of elements. I have the mean here, and I will have these elements here. Let's say that this value is 5, and here you have, I don't know, 4, and here you have 3, okay? And here you have 0 or 1, well, 0. And here you will have maybe 6, and here maybe you have 8 and 10. Okay, these are my elements. So the question, which elements are within 3 standard deviations below the mean? So standard deviations, a unit of length below, so I'm going to the left. So this is 1 standard deviation, right? This will be 1 standard deviation. This will be 2 standard deviations. And this will be 3 standard deviations. Now, this guy that is a unit of length, we know that this is 2, this is 2, and this is 2, that is the length. So, okay, drawing this a little more precisely, I will have element 0 maybe around here. Okay? So, which are the elements that are within 3 standard deviations? So, we mark those ones. 3 standard deviations below the mean will be 1, 2, 3 standard deviations. Each unit takes the value of 2. So it will be, the elements will be 0, 3, and 4, right? This is within that range because this number right here will be 3, this will be 1. This guy right here will correspond to -1. So all values that are above -1 are within 3 standard deviations from the mean. So these 3 numbers will be my answer, okay? So check that I put like draw little blocks because that is a unit of length, the standard deviation. So that's 1, 2, 3 standard deviations. And depending on the exercise, I know which is the value that the standard deviation is going to take. I hope that this is clear enough. Again, as always, this is a quick review. Whenever we got and you start checking the videos on the exercises themselves, you'll see how we apply this concept, and probably you will be able to clarify or to consolidate this concept more in detail. Again, any questions, doubts that you may have, email me and I'll get back to you as soon as possible to help you clarify these concepts.